Guys, we are going to look at qualitative analysis. Remember, in chemistry we are having quantitative and qualitative analysis present, but in qualitative we are only interested in its presence, so we are only confirming whether it's there or not. So we are having our sample here. It is green in color, and before you do any practical, you need to do what we call preliminary test. First of all, you have to see the color. So seeing the sample, since it is green, we can suspect it can be a sort of copper or a sort of iron. So you can say, since the sample is green, you can say that maybe copper 2 and iron 2 ions are present. So after seeing the color, so we are going to deal with the colored cation or cations. So you need to feel the texture. So if you try to feel the texture, it is crystalline. And being crystalline, it means we can suspect either a sulfate or a chloride, because it is crystalline, as you can see here. Now, after that, in this case, in this practical, we are not going to involve heating. We shall heat in the other series. So we are going to dissolve our sample directly using distilled water. And before using distilled water, I should use a small portion. Get our test tube. So you use a spatula. You get a sample, so you add it there. So after that, we add water. Don't just add tap water, we add distilled water. You shake the sample so that it dissolves thoroughly, if it is to dissolve. So as you can see, it is dissolving. So it is soluble, forming a pale green solution, as you can see here. So since it is forming a pale green solution, we can suspect that it's either copper 2 ions or iron 2 ions. Remember, I'm calling them copper 2 ions because copper has valence 2 and valence 1, and iron has valence 2 and valence 3. So there we qualify to call it copper 2 or iron 2 ions. You can see it as fully dissolved, and we are going to divide it into other parts. So we are going to get our test tubes here. So remember, you should use test tubes which are very clean. So you are going to divide small portions. Test tube, we are going to add sodium hydroxide. But remember, the way we hold our test tube, we hold it like this so that you can be able to see what's happening down here. So you don't hold the test tube like this as you are adding the reagent. So you hold it like this. Then as we are adding the reagent, in this case like the solution, then you bring it here. So as we are adding, you should be able to observe what happens if you add a first drop. Drop 1, think you can see in there is a solid which is formed, and practically we are calling it a precipitate, or you can call it a PPT. And in this case it is blue in color. So this is the first drop. We are going to add dropwards until in excess. So we add. So I think you can see a blue precipitate, or you can say a pale blue precipitate. So let's add and see whether it's going to dissolve. So we are seeing our PPT is persisting. So this excess is enough, or you can add if you want. So here the observation is a pale blue PPT insoluble in excess sodium hydroxide, and in this case we are suspecting copper 2 ions. So we are eliminating iron 2 ion because iron forms green PPT, so it cannot form a blue PPT. So we are only remaining with copper. But however, we cannot confirm that it's either copper or not, because this is not a confirmatory test for copper. So let's put it aside. So when you are adding aqueous ammonia, you should be able to observe what happens when you add the first drop. So the first drop, so you are seeing a pale blue PPT. So we are going to add until in excess. So we are seeing a certain deep blue color. So in this case, our first pale blue PPT, it is soluble in excess aqueous ammonia to form a deep blue solution. So it means here we can confirm copper because it's only copper which has this behavior. So the first PPT it is due to formation of copper 2 hydroxide. And copper 2 hydroxide can dissolve in excess ammonia to form a soluble complex. At this step we can confirm copper 2 ions. So you can write and say copper 2 ions confirmed present. So let's try to add potassium iodide, because copper can also be confirmed using potassium iodide. So in this case, we are going to add 4 drops of potassium iodide. Yeah. So we are seeing, though the color can try to confuse, so this is a white precipitate in a yellow or brown solution, but if you try to observe here down, you can see that the precipitate, they are white in color. Or let me say they are colorless. So they are white, and the solution for it is going to be brown or yellow. So you are going to record and say white PPT in a yellow or brown solution. And here I can say copper 2 ions confirmed present. Remember, if it was lead 2 ions, the ones which are non-colored, and we add potassium iodide, see what will happen. So to get, this is a yellow PPT, but in this case for copper, we are getting a white PPT. You can see it down here in a yellow solution. So here you can say copper 2 ions confirmed present. Remember, this is not part of our study. So after that, let's investigate the anion which are there or which is there. So at first we are going to add lead 2 nitrate. So our lead 2 nitrate, we are going to add dropwise. We are going to add 3 drops. So we add, first, we are seeing the color. This is a white precipitate, though it is in a pale green solution. So we add. Now we are getting a white PPT. And let's try, remember this procedure is followed by nitric acid, which is dilute. So in this case, we are going to record and say white PPT insoluble in nitric acid. You can see there, say white PPT. So it's only 2 anions which can give this, suspecting it to be either chloride ion or sulfate ions. So your deduction or conclusion, you are going to say chloride, sulfate, suspected present, or you can just say present. So since we are having 2 anions, that is chloride or the sulfate, we need to confirm 1. So we are going to add silver nitrate, followed by nitric acid, which is dilute. So we are seeing we are having a white PPT there. And let's add also nitric acid. So it is non-dissolving. So the observation is going to be white PPT insoluble in the acid, and this is a comparative test for chloride ion, because this is due to formation, the PPT is due to formation of silver chloride, and it is insoluble in the dilute nitric acid. So we are going to say white PPT insoluble in the acid, and the deduction is going to be chloride ions confirmed present. Let's go through the summary. So remember our sample is here. We dissolved it in water and we formed a pale green solution or a green solution. So when we are on addition of sodium hydroxide, we got a pale blue PPT insoluble in excess sodium hydroxide and suspected copper. So when we added aqueous ammonia in excess, the pale blue PPT dissolved to form a deep blue solution. When we added potassium iodide, we formed a white PPT in a brown solution, and we confirmed copper 2 ions. When we added lead 2 nitrate, we got a white PPT, suspected chloride and sulfate ions. When we added silver nitrate, we got a white PPT insoluble in the acid, and we confirmed the chloride ions. Therefore, from this point of view, we can conclude we're using a sort of copper 2 chloride, because we got our cation as copper 2 ion. We confirmed it using aqueous ammonia and potassium iodide. And we got our anion as chloride ions. So it means we had a combination of copper 2 ions and the chloride ions. So our salt is copper 2 chloride.